There's a factorization of a number called its prime factorization. Just like the name suggests, we're factoring a number with only prime numbers. For example, take the number 12. 12 we can factor a lot of different ways, 6 times 2, 3 times 4, but its prime factorization is 2 times 2 times 3. Did you see that? Because that's only using prime numbers. Now, of course, we can utilize exponents and all that. 2 squared times 3 is the prime factorization of 12. Now, if you get a larger number, say like 80, and you want the prime factorization of it, you can do your tree. 2 times 40. 40 is 2 times 20. 20 is 2 times 10, and 10 is 2 times 5. Just start factoring it until you only get prime numbers. So that's 2 to the 4th power times 5. Okay, so that's prime factorization. Now, why I mention that here is let's go back to the number of factors problem. If you have the prime factorization of a number, and you want to know the number of factors, that is, if you wrote out all the factors, how many factors does it have? Here's what you can do. You take each power in your prime factorization, add 1 to it, and multiply those together. The number of factors a number has is you take the powers in your prime factorization, increased by 1. Multiply all the powers in your prime factorization increased by 1. And that'll give you the number of factors, interestingly enough, the number of factors a number has. For example, for 12, the number of factors of 12 would be increase that prime power by 1, be 3. What's the power on the 3 there? First power? So increase that by 1, that's 2. So 3 times 2, so that tells me 12 should have 6 factors. 6 distinct factors. If I wrote the factor list of 12 out, what are the factors? We can check that pretty easily. 1, 2, 3, 4, 6, and 12. 6 factors. Sure enough. Now, 80, by this little formula here, the number of factors of 80. Well, if I increase the power of the 2 by 1, that would be 5. Multiply then this power, the 5, increased by 1. That would be 2, so that should be 10 factors. Now we did the factors of 80 a while ago. And it was this. Here's the factors of 80. It was 1, 2, 4, 5, 8, 10, 16, 20, 40, and 80. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Sure enough. it works. So it's just another interesting little detail. Also, it gives you, this is another, if you're doing those factors lists, it gives you another way to check to see if you got them all. You know, if you have a larger number, it's interesting to see how many factors you would get out of those. Oh, that'd be a good one. Yes, I'll do another one. All right, let's do 360. How many factors does that have? Well, I could list them all out, but if I use the prime if I just want to know how many there are, let's just do the prime factorization. If I do 360, the prime factorization would be we can just start with 2 times 180, then do 2 times 90, and then 90 is 2 times 45, and then 45, you could do 5 times 9, and 9 is 3 times 3. So the prime factorization of 360 would be what? 2 to the third times 3 squared times 5. Right? 2 to the third, 3 squared, and 5. So then the number of factors, just increase those by 1. So that's 4, 3, and the 5 is 1 power, so that'd be 2. See that? Just increase each power by 1. Just the powers. Increase each power by 1. 4 times 3 times 2 is 24. Depends on how big the number is. But it's just interesting. I mean, who would think that? Who would think that this would match how many factors are? It's just an interesting, just pointing out some interesting little tidbits on numbers you may or may not know. Okay. All right. So I've got one other thing to mention in this section, and that is the divisibility tests.